Page 33, continuing lesson 1.5 on solving equations using square roots and cube roots. So if you look at example 3, they're wanting us to solve for these variables. There's no word problem or anything here. It's just saying solve for the variable, solve for x. So we're figuring out what value or values would work for this equation. So for part A, we've got x squared equals 50. Always for solving for a variable, we're going to do the opposite operation. So x is being squared. To get rid of the square, we're going to put a square root. And my recommendation, like we've been talking about, right away when you put the square root on both sides, I would go ahead and also add a plus or minus. The book did that on the next step, but my concern is that if you don't put it right away, you're going to forget about it, okay? So when we add a square root, we add plus or minus to show that there's two different options that'll work here. And square root of 50 is irrational. It doesn't come out evenly. So unless they tell us to, round the answer to the nearest tenth, or if it's like a real life problem and we're trying to figure out, what does this number actually mean? In this case, we're just solving for x. We really don't know the context of like what's happening or why we're solving for it, other than they told us to solve for it. So we can actually just leave it like that. So plus or minus square root of 50 would be our answer. Okay, which means either it could be square root of 50, or it could be negative square root of 50. Part B, x cubed equals 37. So the variable is being cubed, so we need to take the cube root. When you take the cube root, you do not add plus or minus because you've actually got three factors. And it doesn't work out to where we can have a negative, because, positive times positive times positive is positive. That's good. But if you did negative times negative times negative, negative times negative is a positive, and then a positive times negative is negative. So it doesn't work for us to put that a negative answer would work also, unless there was a negative there already to start with. If there was no negative to start with, we're not going to add anything for a cube root problem. So cube root of 37, and that doesn't come out evenly either. So I know that's maybe not a very satisfying answer, but that's our answer for this problem. So if we look at the try it part A, we are solving a cubed equals 11. I'm just going to rewrite it underneath, just so I've got a little bit more room. So this one, the variable is being cubed. To get rid of the cube, we're going to need to take the cube root. Cube root on both sides of our equation keeps our equation balanced. Okay, so cube root and the cube cancel each other out, which just leaves us with an a. And cube root of 11 doesn't come out evenly. And remember, for cube root, we don't add plus or minus in front of it. So since it doesn't come out evenly, and they don't tell us really any more directions on what to do, we're just going to leave that as our answer. A equals the cube root of 11. Okay, and we could figure out approximately what it is if we're interested, but this is really all we need for this problem. If we go to part B, they want us to solve c squared equals 27. So this time the variable is being squared. To get rid of the square, we would do the square root. Remember, square root, you could put a little 2 inside the index, or the kind of check mark looking thing. But we don't need to do that. Since we are doing a square root this time, we will put plus or minus, because you could have a positive times a positive equals a positive, or a negative times a negative equals a positive. So this one, square root of 27 doesn't come out evenly. It's about 5 point something. And so it doesn't come out evenly either, so we'll just leave it as plus or minus square root of 27, which again means either square root of 27 or negative square root of 27. So the key concept, if a variable is being squared, we can do the square root, and then we can go ahead and put plus or minus on that. If we have a cube root, or if a variable is being cubed, we can take the cube root on both sides. So if we look at the do you understand number 2, Surrey solved the equation x squared equals 49 and found that x equals 7. What error did Surrey make? So the problem is x squared equals 49. To get rid of the square, we're going to do the square root. And we have to remember when we do a square root, we need to put plus or minus. And square root of 49 is 7. So the 7 part's okay, but the problem is Surrey forgot to put plus or minus. Seven times 7 equals 49. Also, negative 7 times negative 7 would equal 49. Number 3, there is an error in the work shown below. Explain the error and provide a correct solution. So variable was being cubed. They took the cube root. Cube root of 125 is 5, but then if you look at their answers, they said x equals 5 and x equals negative 5. So the problem with that is that this part we don't need, because when you do the square root, or sorry, when you take the cube root, you don't put plus or minus. So they kind of had opposite problems here. The last person didn't put plus or minus, and they should have. This one put plus or minus, and they shouldn't have. So the answer should have just been x equals 5 only. Okay, and again, the problem with that, this works. 5 times 5 times 5 is 125. But if you do negative 5 times negative 5 times negative 5, that's negative 125. Number 4, why are the solutions to x squared equals 17 irrational? So the deal is, if we were going to solve this thing, they're squaring, so we would do square root, we would do plus or minus, so we do have solutions, right? 2 solutions to this. And then if we tried to do square root of 17, the problem is it's not a perfect square. It's in between 4 and 5. So it's irrational. The decimal is going to keep going and doesn't repeat. So this is a way of how we could write that out, something to this effect. 17 is not a perfect square, so square root of 17 doesn't come out evenly. The decimals keep going and don't repeat. We go to the do you know how, number 5. If a cube has a volume of 27 cubic centimeters, what is the length of each edge? Use the volume formula V equals S cubed and show your work. Okay, so a starting point we could have done, we've talked about, would be volume is length times width times height. It's just that on a cube, the length, width, and height are all the same. So that's how they got the S cubed. Okay, so if that's our equation we're using, and they tell us the volume is 27 cubic centimeters, we're just taking that equation, we're substituting a 27 in place of the V, in place of our volume. And then we're going to solve for the side length. So since the variable is being cubed, we would want to take the cube root. Cube root on both sides. Cube and the cube root cancel out. And then the cube root of 27 is 3. 3 times 3 times 3 equals 27. And so that means each side on this cube would be 3 centimeters. And if you think about it, that works with our volume that we said, because if we did length times width times height, 3 times 3 times 3, we would get 27 cubic centimeters. Look at number 6. Darius is building a square launch pad for a rocket project. Area of the launch pad is 121 square centimeters. And the question is, what is its side length? So they're telling us to use this area formula. And once again, we could back it up a minute and say, area of a rectangle or area of a square is length times width. It's just that on a square, the length and the width happen to be the same. So that's where they got the A equals S squared. So we're just going to take the formula, we're going to substitute what we know into the formula, and then we're going to solve it. So they told us the area of the launch pad is 121 square centimeters. So we're going to put 121 in place of the A, and then we're going to solve this thing. So since the variable is being squared, we can take the square root on both sides. Remember, when you take the square root, we're going to go ahead and add the plus or minus in front of it. Square root of 121, a number times itself that equals 121 would be 11. 11 times 11 is 121. So either, we're saying right now, either the dimensions would be 11 centimeters by 11 centimeters or negative 11 centimeters by negative 11 centimeters. Well, we can't have a negative dimension, so we're going to cross out the negative, and then our answer would just be 11 centimeters. So look at number 7. They want us to solve the equation x cubed equals negative 215. So this one, I think, is the first one we've had where we've had a negative number in our equation. So to get rid of the cube, we have to take the cube root on both sides. Remember, for cube root, we don't need to add plus or minus. On these, if you're entering this in your calculator, you do cube root, and then to do negative 215, for the negative, you have to use this button. It's got an A and S above it, okay? You have to use this for the negative 215. If you use the other button, it's on these calculators, it treats that just for subtraction, and it'll give you a syntax error. So this doesn't come out evenly, and there's no story to it that we know really what's going on here. So we can actually just leave this as cube root of negative 215, okay? It would be, the answer would be negative, because negative times negative times negative equals a negative. But that would be it. One thing else I want to mention here, it's not in your book, but if we had x squared equals negative 215, okay? I know that's not in your book, but let's just talk about that one for a minute. So since the variable is being squared, we would do the square root. When we do square root, we would put plus or minus. And then you could just do that. It's not a real great number. We could just type that in the calculator. So if you do that on your calculator, what's going to happen, it should say something like domain error. So this one actually doesn't work. So this equation actually has no solution. We'll get into that more later in the year. Okay, this is just kind of a bonus little side lesson for you here. The reason this doesn't work, the reason you get a domain error is because when you're doing the square root, you're saying what number times itself equals negative 215. Well, if it was a negative number, negative times negative is positive. And if it's a positive number, positive times positive is positive. So there's no way we can take a number times itself and get a negative number. That's not going to work. So that's the reason why that doesn't work. And like I said, I know the book's not explaining or talking about this at this point, but just kind of a side note while we're talking about it. So this gives you an idea of how to solve equations using square roots and cube roots. Have a good day.